In this video, I'd like to give you a little more insight or a little more visual into exactly why stars twinkle. So here's sort of the setup for you here. Imagine that you're over here on Earth, and that's your eyeball right there, and you're looking up into outer space at some stars, or maybe a star. So the reason why you see the star is because this light ray right here from the star travels all the way across the galaxy into our solar system and eventually into your eye. It's quite remarkable actually where this light has been by the time it reaches your eye. But just imagine it traveling and traveling and traveling and traveling. And it's in the vacuum of outer space, and so of course there's just nothing in its way. There's nothing. The index refraction of 1, exactly 1, it just keeps traveling, nothing in its way. Then what happens is it starts to approach your eyeball over here, it encounters something around here. What would that thing be? Well, the Earth's atmosphere, right? The Earth's atmosphere is going to be in the way. Now, it won't be this large compared to the small Earth that I have here, but I think you get the point that before the light ray that traveled all the way through the galaxy, completely unobstructed for many light years, by the time it gets near your eye and wants to enter your eye, it has to go through the atmosphere first. And so what happens, of course, is right around here, right around this boundary right here, this is what that light ray, after all that travel time, is finally going to encounter. It's been living in the vacuum of outer space, index refraction of exactly 1 for all this time. But then it hits this boundary right here between space and atmosphere, right? And the air starts. Now, it isn't this abrupt, but the idea is okay. And what happens is when the index refraction changes from 1.00 to 1.007 or something like that, from vacuum to air, the light ray is going to bend. It's going to refract. Light always does this when it encounters a different boundary. It's going to refract. So here's the original path it was on, but it's going to bend a little bit now. That's the bending law. And as we know, the atmosphere is a very unstable place. There's no reason that the index refraction would always be a constant like that. So maybe sometimes that 7 at the end there will be a 5 1 second, then an 8, then a 10, then a 15, then a 0, then a 20. It's just going to be fluctuating all over the place, which is going to cause this bending angle to fluctuate also. So this bending angle might be here, then it might be there, then it might be up, then it might be down, then it might be there. It'll fluctuate all over the place. And so what you end up getting when all is said and done is, let's just say that this end of the light ray right here, the way I've drawn it, or this stick here, is right where the light ray encounters the Earth's atmosphere. So the refraction is going to happen right here. And this is sort of the continuation of the light ray. It's going to get into this position right here, but it's just going to be fluctuating around. It's going to be moving all over the place like this. So I'm trying to keep this point of refraction fixed back here, but it's just going to fluctuate all over the place. Sometimes it's in your eye, sometimes it's above your eye, sometimes it's down all over the place. Now the star doesn't completely extinguish itself, so it's not like the light ray completely leaves and doesn't go into your eye at all, but it's definitely sort of wobbling around your pupil like that because of all those index refraction changes in the atmosphere. And for that reason, the star then is going to appear to twinkle. It's not a nice constant light source, light ray that stays nice and fixed like this going into your eye, giving you uniform illumination. It's up and down and left and right and all over the place sort of on a quick basis like that because of the fluctuating index refraction of the atmosphere, and that's why the star is going to twinkle. Now, as we contrasted that with a planet, of course, for a planet, this light ray here is pretty similar in nature. It didn't travel that far because it's a planet after all. It's just coming in from our solar system. But because the planet is larger, where there won't be one light ray, there might be many light rays. Like there's a second light ray coming in from the planet. Maybe there's one over here or down here. There's a whole bundle of light rays coming in from the planet. So it's okay if one of these light rays might refract out of the way because of the Earth's atmosphere, but no sooner then this one is going to refract out of the way. By golly, there's going to be another ray in this bundle to fill in where this one might have left. So you won't even notice the fluctuation at all because this one might have fluctuated out of the way. This one's going to fluctuate in the way. Either way, you get the full light ray going into your eye. And so that's why planets do not twinkle in the night sky. Only under very extreme atmospheric conditions would you actually see a planet twinkle. But in a sort of normal, calm viewing conditions outside, the stars will twinkle, but the planets will not.